This video will show you how to do inline AI code completion in a web app using Mozilla's Llamafile. If you haven't heard of Mozilla's Llamafile, it allows you to run local LLMs from a single file as opposed to using something on the web like ChatGPT where you have to pay and they collect your data, etc. So the first thing we're going to need is a Llamafile itself, and you can get those from Hugging Face. What I like to do is search for coder Llamafile. You see we've got various options here. You don't want an instruct model, that's for chat. What we're looking for is something without instruct in the name. Those are the base models. So here's one called DeepSeek Coder. 1.3b stands for how many parameters it has, 1.3 billion. You can see these up to 70 billion is common. So this is a very small model, and we'll see that if we look at the files. Here's the Llama file, and it's 1.2 gigabytes. So we'll go ahead and download that. And so I keep all my Llama files in a single directory. And if I look at that directory, I've got DeepSeek Coder here. So I'm just going to open up a terminal window. I'm going to change to that directory. And then I'm just going to run my Llama file with whatever it's called. And then I'm passing these two parameters here, -- no browser and -- server. That's just going to keep it from opening up any kind of UI, and it's also going to be running Llamafile in server mode so that it will be listening for requests to its API endpoint. And Llamafile by default runs at port 8080, so that's where we're going to be sending our API requests for those code completions. Okay, now the code for the web app I just generated using Claude from some code I knew already worked. So in Claude, if you've never used it, they have these things called artifacts. Artifacts give you an interface on the web for testing out AI-generated code. Basically what I did is I provided it my TypeScript files for inline completion using Llamafile and a little debouncer class that helps me not hammer the API of Llamafile with constant requests if the user is still typing. And I said, I have this inline completion code, turn it into a web project that can be hosted. And Claude created that app. It showed me how to install it, and I went back and forth a little bit to customize, remove some of the UI components it had suggested out of the box, but eventually it gave me some working code. And so I'm going to use that code and turn it into a working React web app. Okay, so I'm in VS Code in a new folder here, and I'm going to create a next.js app, call it Code Completion Web. I'm going to be using TypeScript, using Tailwind and NPM. I'll go ahead and use ESLint for any errors. Put everything in a source directory. Use that app router. Don't need to customize any of that stuff, so I'm just accepting the defaults there to start it up. It's creating my app. It's installing all the dependencies, and I'm going to change into that code completion web directory, and we should be good to go. So if we look inside the source code here for that web app, what it gives us out of the box is boilerplate React app. We can run that app choosing npm run dev, start that up, and we see we've just got this boilerplate app. I'm going to make a folder called components and a file called code completion app.tsx, and I'll paste in the code from Claude. Then I'm going to go to the file that kicks this stuff all off, which is the page.tsx file in the source directory app root. And I'm just going to delete all this boilerplate and paste in a very simple app. You can see we've got this route home, and it's including our code completion app component, which we are importing here from the components directory that we just made. So that's all we need to run this app. So I'm going to open up that localhost 3000 URL, and I will just start writing some JavaScript code here. And you can see it's suggesting completions. If I accept one of those, it's just going to paste it in there. So let's just look at the code and see what it's doing. Caveat being, this is AI generated code. It's not great, but it's simple. So we've got some state variables here to keep track of the state of the app. The input code is the code that we actually see in the box. The completion itself is what's coming back from Llamafile, and we are assigning that to the input code state variable when it's ready, when it's been debounced, etc. If Llamafile is busy generating a response based on what we typed, it sets this is loading variable, and we saw that little loading spinner a few times maybe while I was typing, and it's trying to keep track of the cursor position so it knows where to insert the accepted completions. So this is the code that I gave to Claude to begin with. Basically, all we're doing is a fetch request to port 8080, where that llama file is running, /completion. That's to get non-chat completions from this model. And we don't need any sort of API key or anything like that. That's the great thing about running a local model, is you don't have to pay for anything. You don't have to get any API keys. And then the model for our Llamafile is just llama CPP under the hood for the moment. I know they're working on revising their server to actually be a bit more performant than llama CPP itself. So, and then this is the prompt template that generally works well with the AI. It's essentially saying, we're going to give you a prefix, the code before the cursor, and a suffix, the code after. And in the middle there is all the code that we want you to insert. And then we don't want it to insert more than 512 tokens. And you could set this to whatever you want. You can see we've got this stop parameter. So if the model returns any of these, I want Llamafile to stop generating content for me. That includes any of the stuff from this template that I gave it, end of texts, which the model will return when it has finished all the code it thinks it needs to generate, and then any sort of like double new line character, which would indicate maybe the start of another function or declaration or something. Then we just get a response back, and if it happens to have these things in the response, I'm just going to strip them out before I return it to that text field. So that's it. That's basically how we are rendering all of that code. And then as far as all the React stuff goes, this is the code that Claude generated for us. It's basically just listening for a React change event on that text area. And if it has new text, it grabs the value, it sets the cursor position, it uses our debouncer, and if enough time has passed between the last keystroke, it will go ahead and generate that completion. If not, it sets this is loading is true, it displays the loader, and it waits for the debouncer to say, okay, go ahead and generate a completion.